In the movie Interstellar, Cooper and his crew manage to dock with the Endurance after escaping from the ice planet. Then, as he sacrifices himself and falls into the black hole, he enters a higher dimensional space called a Tesseract, which he braved death to enter. But why was this Tesseract located within the black hole? A black hole has such strong gravity that nothing, not even light, can escape from it. According to theory, this singularity of the black hole acts as a physical wormhole, serving as a passage to higher dimensions. So rather than saying that the Tesseract was inside the black hole, it might be more accurate to say that the black hole itself was the gateway to the higher dimensional Tesseract. But how could a human being, clad only in a spacesuit, physically enter a black hole? There may be many of you wondering if that makes any sense. Surprisingly, it's possible. Generally, if you were to dive into a black hole, your body would be stretched out like spaghetti, torn apart, compressed, and decomposed into atoms or smaller particles, leading to death. However, if the black hole's mass is big enough, it is possible for a spaceship to approach it, and even for a human to get near it. In the movie Interstellar, the reason the planets and spaceship weren't destroyed, and the reason Cooper wasn't stretched out, is because the Gargantua possessed an immense mass. According to the movie Interstellar, Gargantua's mass is approximately 100 million times that of the Sun. So it's not just a movie you casually watch and move on from. It's a portrayal that has undergone rigorous scientific verification. The next question is, given that the gravity of Miller's planet is almost similar to Earth's, how can the waves be so gigantic? Miller's planet was an oceanic planet, covered with a significant amount of water on its surface. Despite the depth only reaching up to knee height, the waves were astoundingly enormous. Dr. Cooper and Brand initially mistook this for a mountain.
Where's the mountains?
Those aren't mountains, they're waves.
In the film, the height of the wave was 1.2 kilometers, which is about 3/4 of a mile. You would never see such a gigantic wave in shallow water on Earth, but why was the wave so big on Miller's planet? This phenomenon is due to the gravity of the black hole, Gargantua. The tides and tidal ranges that occur on Earth are all due to the gravity of the Moon. However, right in front of Miller's planet, there is a black hole with tremendous gravity, so it's an environment where waves can inevitably become high. Physicist Kip Stephen Thorne said this because Miller's planet is not completely fixed to Gargantua and is shaken repeatedly to the left and right. A gigantic wave comes rushing to this planet every hour. The fact that a gigantic wave could occur even though the depth is so shallow is because most of the water on the planet is concentrated on that wave. So why does the supermassive black hole, Gargantua, have a ring? The image of a black hole as we used to know in the past was like this. There is a region called the event horizon around the black hole, and in this place there is a collection of photons circling forever, neither escaping from the black hole nor being sucked into the black hole.
We can't get anything from it.
Nothing escapes that horizon, not even light. Oh, the answer's there.
And outside the event horizon is a disc-shaped dust vortex firmly attached, the so-called accretion disk. This accretion disk shines beautifully, giving a quite mysterious feeling. But then a question arises. How can a black hole, which is said to absorb everything, emit light? Of course, the black hole does not emit light by itself. However, The accretion disk emits light because tremendous energy is generated due to friction between rotating gases. This is the same for the black hole M87, which humans photographed for the first time on April 11, 2019, and the black hole at the center of our galaxy, the Sagittarius, a star, which was photographed on May 12 last year. Cooper and his team arrive in a universe 10 billion light-years away by riding a wormhole created by future humans. One might wonder, how could this happen? Is it even possible? Let's think of it this way. Suppose there's a bug on the surface of an apple. The quickest way for the bug to get to the exact opposite side of the apple is to burrow straight through the core. A wormhole operates on the same principle. It essentially burrows through different spaces like an apple, creating a shortcut. Physicist Kip Stephen Thorne said this: "If there is a tremendous amount of both positive and negative mass, a wormhole connecting different spacetimes can be created." In theory, this would allow humanity to journey billions of light-years away. However, the existence of wormholes is only theoretically possible at this point. No wormholes have been observed or experimentally validated. Furthermore, even theoretically, wormholes present many problems. The walls of a wormhole collapse too quickly for anything to pass through. To traverse a wormhole, a specific medium is required to maintain the wormhole's wall. But it's illogical to claim that modern humans, who haven't even discovered a wormhole yet, possess the technology to maintain one. Hence, in the film, it's assumed that future humans have created and continuously maintained the wormhole. Guess what? Wormholes also appear in Marvel movies. It's the Bifrost used by the Asgardian. The Bifrost, serving as a shortcut between different spaces, shares a common thread with wormholes. So in the movie Interstellar, the Asgardians may have actually created a wormhole in our solar system. Will humanity transcend time and space, meddling with cosmic threads beyond our understanding? Or are we mere players in an unfathomable cosmic drama as the dream of a universe awake unfolds? The mystery lingers in the stardust of our collective imaginations, weaving an endless interstellar tale. In our next documentary, we delve deeper into the heart of our solar system and explore the genesis and evolution of our own star, the Sun. So prepare yourself for a stellar journey as we uncover the secrets of the birth of stars, revealing the fascinating symphony of cosmic processes that lead to the creation of light in the vast darkness of the universe. Until then, keep looking up and never stop wondering.